Hi, and welcome back to our chemistry flipped classroom. Today, we're continuing our conversation about atomic theory, and we're talking about isotopes. So let's go ahead and define what an isotope is. We really can't define an isotope. We have to define them as a group. So isotopes are atoms of the same element that have different masses due to varying numbers of neutrons. And so we can have lots of different isotopes of some elements. Some elements have only one isotope. So let's go ahead and talk about what that means. So they have different masses because they have different numbers of neutrons. We know that the proton is the defining factor of what makes an element. So hydrogen is always going to have one proton. And if it is the atom and not an ion, it's also always going to have one electron. So it's a neutral atom. And so we have the same number of protons that we have electrons. Typically, hydrogen is what we call hydrogen 1. And so in its nucleus, it has only a proton and no neutrons. And so it has a mass of 1 atomic mass unit. And that's why we name it hydrogen 1. That little 1 at the end of its name tells us that its mass number is 1. If we were to move on to hydrogen 2, it has both a proton and a neutron in its nucleus. And so now it has a mass of 2 atomic mass units. And then finally, we can move on to hydrogen 3, which has still 1 proton, but it has 2 neutrons, and it has an atomic mass of 3 atomic mass units. So we have the same element, it has the same chemical characteristics, but it is going to have different nuclear decay characteristics, and it's going to behave just a little, it's going to have a different mass. So we'll talk about 2 different things when we talk about mass. We'll talk about mass number and atomic masses. So let's go ahead and jump into mass number. So mass number is always going to be a whole number. It is the number of protons and neutrons in the nucleus of an isotope. So again, it's a whole number, and it's protons plus neutrons. So let's take a look at a few examples. So we can look at oxygen, and if we look at our periodic table, we can see that oxygen is going to have 8 protons. This particular isotope of oxygen has 10 neutrons. Since it has 8 protons, we know also that it's going to have 8 electrons. And its mass number is going to be the 8 protons plus the 10 neutrons. So it's going to be 18. And so we would name this oxygen 18. So now the next one, we're going to have to take a look at our periodic table and find what element has 33 protons. And remember that 33 is the number of the element. So 33 protons, we take a look and we see that we have arsenic. And if we have 33 protons, we must also have 33 electrons. And now for our mass number, once more, we're going to add the protons and the neutrons, and we're going to find a mass number of 75. And so we're going to name this arsenic 75. Now in this one, we're given the number of protons again, and so we're also given the mass number. So we'll go ahead and fill in our mass number is 31. And then we'll take a look at our periodic table and we'll see that element 15 is phosphorus. So we now know that we have phosphorus 31 with 15 protons and a mass number of 31. If we want to find the number of neutrons, we're going to have to subtract 15 from 31. So we'll go ahead and fill in the electrons. We know they're equal to the number of protons, so 15 electrons. And then subtracting 15 from 31 gives us 16. So we know that phosphorus 31 has 16 neutrons. So notice these are all whole numbers, and a mass number is always going to be a whole number. It's always going to be the sum of the protons and the neutrons. That's mass number. Now we'll also talk about atomic mass. So atomic mass is the average of all the naturally occurring isotopes of that element. But we want to account for how abundant they are. So if we were to look at carbon as an example, in nature we find carbon 12, which has 6 protons and 6 neutrons. We find carbon-13, which has 6 protons and 7 neutrons. And we find carbon-14 that has 6 protons and 8 neutrons. Now, if we were to sample all of the carbon in nature, we would find that there is a tiny, tiny, tiny fraction of it that is made up of carbon-14, and a relatively small fraction that's made up of carbon-13. And the vast majority of that carbon is carbon-12. 98.89% of carbon is carbon-12. And so the average atomic mass, or what we call atomic mass, is a weighted average. So we're going to take the percent of carbon that is carbon-12, 98.89, and we're going to multiply 12 by 0.9889 because 98.89% of it is carbon-12. And we're going to multiply the carbon-13, so the 13, by 0.0111 to account for how much of it is carbon-13. And we would actually need a number here. It's, I think, 0.0002. I could be wrong about that. But it's a very small fraction, and we're going to multiply that, and then we'll add them up. And we'll find that carbon's average atomic mass is 12.011. Now, if you're looking at your periodic table, you'll notice that this is the number that is written on the periodic table as the mass of carbon. This does not mean that any individual carbon atom is ever going to weigh 12.011 atomic mass units. It means that if you were to take a sample of carbon, that the average is going to be 12.011. So we can take all of this information and we can put it into this format that we call standard atomic notation. And so standard atomic notation, we're going to use the symbol for the element here with the X. We're going to put the number of protons over here to the left at the bottom, and that's our atomic number. And at the top, we'll have our mass number in atomic mass units. Now notice this is the mass number, not the atomic mass. So for example, if this were carbon, we would have a C here for carbon. We would have a 6 here for its number of protons, or its atomic number. And we would have a 12, a 13, or a 14 up here for the mass number. Okay, mass number, atomic number, element symbol. Let's take a look at a few of these examples of isotopes, and we'll see what we can figure out. So we're going to take a look at just this one, and then we'll go over the rest of these in class. So we're going to look at this element, and we're going to try and figure out what it would be. So we're going to count the number of protons, and we can see that we have 6 protons. So that tells us right off the bat that this is carbon. And we have 6 electrons, so we know it is neutral carbon. But we have 8 neutrons. So with 6 protons and 8 neutrons, the mass number of this carbon is 6 plus 8, so it would be carbon-14. And so we have the number of protons telling us what atom it is, and our mass is given by the sum of the protons and the neutrons. All right, one more, and then we'll be done for the day. Given 1, 2, and 3 here, we want to know which ones would be isotopes. So you can go ahead and pause the video here for a minute and check and see which ones you think would be isotopes. So we're going to count, and we have 1, 2, 3, 4, 5, 6, 7, 8 protons in element 1 here. And we have 1, 2, 3, 4, 5, 6, 7, 8 protons in element 2. And we have 1, 2, 3, 4, 5, 6, 7 protons in element 3. So in order to be isotopes of one another, they have to have the same number of protons. They have to be the same element. So 1 and 2 have the same number of protons. Do they have a different number of neutrons? So if we look at the first one, we can see that it has 8 neutrons. And if we look at element 2, we can see that it only has 7 neutrons. And so element 1 and element 2 would be isotopes of one another. And now that we're here and looking, we know that they each have 8 protons. So we know that this element is oxygen, and element 3 is nitrogen because it has 7 protons. And if we were to add the protons and the neutrons, we would get that this is oxygen 16, which is the most common isotope of oxygen. And this is oxygen 15, which is a very uncommon isotope of oxygen. All right. As always, if you have any questions, let me know. I look forward to seeing you in class tomorrow.